This episode is brought to you by Pacifico. When having a Pacifico beer with friends you just met turns into hitting up their friend's local art show, getting inspired to create something together,
look.
and painting your first mural, you found what was waiting for you. Pacifico. Life's waiting. 21 plus only. Discover responsibly. Pacifico Clara Beer. Imported by Crown Import, Chicago, Illinois.
Welcome to the Flash Finds podcast, the world's fastest podcast where we explore how Facebook can help you with the stuff you're into. I'm Emma Rogue, joined by Nathan the Cat Lady, a Facebook creator. So Nathan, if you're into pets, what kind of stuff can you find on Facebook?
Well, I make reels about useful tips for pet owners. For instance, cats don't like still water, so all of my cats have cat fountains.
Oh my gosh, that's so cute. What a great episode. See you next time on the Flash Finds podcast, all about discovering the stuff on Facebook you care about. Bye.
Try new Pure Leaf Blackberry Iced Tea. Discover a world where unexpected blackberry flavor transports you to a berry delicious place. A world so full of refreshing blackberry iced tea that you may never want to leave. However, you will eventually have to. But take your time. Try new Pure Leaf Blackberry Iced Tea. Visit Amazon.com/PureLeaf and enter 20 Pure Leaf for 20% off your purchase of new Pure Leaf Blackberry Iced Tea.
Okay, hey everyone, this is David, ACS Bridge Fellow, General Fellow, founder of the Chemist company. And one of the things we're doing today is we're going to go through an explanation of the central dogma, going through DNA, mRNA codons, and then the amino acids that make up proteins. So, central dogma and its significance as it relates to metabolism. The central dogma, DNA. Let's go through the DNA. So, DNA is made up of nucleobases. So we have adenine. So we draw it, and we're going to use Watson Crick base pairing. This is adenine. We draw the ribose. We put the phosphate there. And then we use our little hydrogen bonds. We attach it to hydrogen bond to thymine, which is a methylated uracil. Then we have it. And then we have the phosphate. And then from there we have this, which is another component. And we're drawing guanosine. And moving it right along, of course it's a little smushed, but we have this. So let me just adjust this. If we move the phosphate, put it like this, do it like this. So, and we have our double bond there. This is a cytidine. Cytidine, triple hydrogen bonds, two hydrogen bonds between adenine and thymidine, and guanidine and cytidine, and we have DNA, and it goes from 3 to 5, and 5 to 3. So we have DNA here, and we also have our hydroxyls there. So that's DNA. So the only nucleobase that we are missing in this instance is uridine, which is basically going to be appreciate bond angles, which is that. And of course, you just attach the ribose and the phosphate. So this is DNA. Moving right along, let's go to RNA. And RNA, I came up with a nifty way to code the codons, the 64 codons. So from DNA to RNA. So we have the structure of DNA. Now let's work through the codons. So uracilcytidine, uracilcytosine, adenine, guanosine. Let me go right down. So I'm using the amino acid one-letter abbreviations. F2, L2, L4, I3, start 4, V4, S4, P4, P4, A4, Y2, stop, 3, stop, 4, H2, Q2, N2, K2, D2, E2, and then moving right along, we have C2, stop, 3, W4, R4, S2, R2, G4. So what we have here are the one-letter abbreviations for all amino acids and their locations on the 64 codon chart. So writing this out, we have U, U, C, C. So writing this out. A, G, and G. So this is phenylalanine, leucine, isoleucine in those three positions. And then moving with this, we also have on this side here UCAG. So you kind of get the trend. So phenylalanine is UUU, phenylalanine UUU, phenylalanine UUC, also can be represented as UUC, and we have that from there. So keep that in mind. This is the representation using the 64 codons. So with that in our minds, you no longer have to write it. We can just go right along to the amino acids that make up protein. This is essential dogma in this canonical way. So we just put this on the side here. And we'll use it as we go through the amino acids. So with the amino acids, we have non-polar. So gavyl, pro, trip, methyl, fen, glycine, alanine, valine, isoleucine, leucine, proline, tryptophan, thionine, and phenylalanine. So glycine, of course, the L-amino form, which amino acids are typically L-amino acid, is going to be one of my friends. Her name is Daj. So I'm like, hi Daj. The hydrogen is on the dash, and the R group is on the wedge, and then we have our carboxylate, and that's that, L-amino. So glycine. Now we're not going to draw these stereospecific. That shows the stereochemistry. We're just going to draw them in the planar form. That's that. Glycine. Now, one of the things we're going to do as we go through this, as we write the corresponding amino acid, we're also going to think of how it will be represented using the 64 codons. So in this instance, right there, we know from our chart that was drawn previously that glycine would be in this position right here. So glycine would be in this section of the chart. We don't have to redraw the chart because we know the chart. So glycine is going to be GGU, GGC, GGA, and GGG. In the last corner of the 64 codon chart. So that's that glycine, alanine. We know what alanine is. We know alanine has a methyl group attached to it. And all of these bond line representations based off of their usual form, we know there's a hydrogen right there as well.
You are very important, especially to us here at the New Chemist podcasting group. You listening in is significant.
Vous êtes très important, surtout pour nous ici au New Chemist Podcasting Group. Votre écoute est significative.
Usted es muy importante, especialmente para nosotros aquí en The New Chemist Podcasting Group. Usted escuchando, es significativo.
Você é muito importante. Especialmente para nós do The New Chemist Podcasting Group. Você ouvindo, é significativo.
Είστε πολύ σημαντικοί, ειδικά για εμάς εδώ στο The New Chemist Podcasting Group. Το να ακούς είναι σημαντικό.
Sie sind sehr wichtig, besonders für uns hier bei The New Chemist Podcasting Group. Es ist wichtig, dass du zuhörst. Je bent erg belangrijk, vooral voor ons hier bij The New Chemist Podcasting Group. Dat je meeluistert, is veelbetekenend.
You are very important, especially to us here at the New Chemist Podcasting Group. You listening in is significant.